Hey everybody, this is our lesson on sound waves and Doppler effect. And by the end of this lesson, you should be able to compare waves based on their characteristics. So we haven't talked much about sound waves, and now we're going to make sure we cover those as well as our other types that we've looked at. So sound waves are considered compression waves, so they are not transverse. They do follow that longitudinal wave characteristics. And the speed of a wave does depend on the medium and its temperature that the wave is traveling through. So it will travel faster through solids and liquids than it does through gases. And it travels faster through warmer materials than through cooler. The speed of sound is less than the speed of light. So if you've ever been to like the beach, whenever someone's shooting off fireworks far away off a pier, a lot of times you'll see them before you hear the boom of the firework. And that's because light will travel faster than sound. So the speed of sound is around 342 meters per second. And the speed of light is around 300 million meters per second. So let's talk about our properties of sound waves. The first one that we look at is pitch. So pitch is the highness or lowness of a sound. So you can see here, I've got a little example here with this picture. So thunder, we know, has a rumble. It can be loud, but the pitch of thunder is very low. But the pitch of like a mouse squeaking is very, very high. And pitch depends on the frequency of that wave. So the higher the frequency, the higher the pitch will be. So the more quickly those compressions are occurring together, the higher that pitch will be. The lower the frequency, the lower the pitch will be. And the human ear can hear between 20 hertz and 20,000 hertz in terms of like what we can register with our eardrums. And then we have what are called ultrasonic tones, which are frequencies above 20,000 hertz. So, you know, they make those like dog whistles that people aren't supposed to be able to hear, but dogs can. That would be like an ultrasonic tone. Or if you've ever had those apps that like they say, oh, if you're over 25, you can't hear the noise anymore because your hearing has deteriorated. Same kind of things there. And then we have infrasonic, which are below 20 hertz. So those are such a low pitch that we can't register them as well. We also have a property called intensity, which is the amount of energy carried by a wave in a certain amount of time. And this is determined by the amount of energy in each wave. So the larger the amplitude of that wave, the larger the intensity will be. And this will determine what's defined as our loudness. Also remember, since your amplitude increases and your intensity increases, that is a direct relationship. So loudness is the human perception of sound intensity. So you guys have heard loud noises before. That means there's a lot of energy being carried by that wave. If it's quiet noise, less energy is being carried by that wave. So the higher the intensity and amplitude, the louder the noise will be. And this is measured in decibels, which I'm sure you've heard that term before. And anything above 120 dBs will hurt the human ear and can cause permanent hearing loss if you're not careful, if exposed to it for a long time. So now that we understand sound waves a little bit more, we can talk about the Doppler effect. And as you can see here, I love Big Bang Theory, and Sheldon here is dressed up as the Doppler effect for Halloween. If you've never seen that clip, you should watch his imitation of the Doppler effect. So this is the change in wave frequency due to a moving wave source or motion of the observer. So the best way to explain this is like a an ambulance. So you've always heard like an ambulance or a fire truck, and it'll sound really, 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 really quiet as it's far away. But as it moves close, if you're staying still, as it moves closer to you, it gets louder and louder. Its loudest is when it's right beside you, and then it gets quiet again as it goes past you. That is changing the frequency, which then is also changing the pitch of the sound, the siren coming off. So this will also cause a change in pitch due to the change in frequency, as we just said. And as it moves towards you, the higher the pitch and the higher the loudness will be. As you pass the source, it will begin to decrease again. So sirens are our best example here. So quickly, let's just talk about what interference is and how that causes issues with waves. So interference is the ability of two or more waves to combine to form a new wave. So we have constructive and destructive interference here. Constructive is when two waves, their compressions will line up at the same time. They'll arrive at the same place. So this means that you're actually going to be able to add those compressions together. It will increase your amplitude, it will increase your energy and your loudness. So if you look at this GIF over here, as these two crests come together, you see how that red wave gets much bigger. That's when it's constructive interference. Then we have destructive, which is where the compression actually lines up with a rarefaction. Here on this picture, it's where a trough lines up with a crest, and they actually cancel each other out. So you subtract the height and the depth. And then that's when you see like the red line quickly becomes like a straight line through this GIF. So we've lowered amplitude, energy,